हेलो।
हाँ यार।
अकेला है तू?
कोई नहीं है यार, इसीलिए चुपचाप बैठा हूँ और क्या करूं।
क्या चल रहा है? किया पढ़ाई किया?
हाँ, वही कोड वगैरह लिख रहा था, वो सब वर्किंग
हम्म,
कोड।
हाँ हाँ, वर्किंग। सही है।
आपका नींद खुला?
हाँ यार, कल थोड़ा फिर से थोड़ा लेट सोया था। आज का पढ़ना था तो अभी मेरा बैक टू बैक है। कल हो गया एक इंटरव्यू, आज है, कल है, फिर परसों है, फिर नरसों है। मंडे टू फ्राइडे रोज एक टेक्निकल, शायद ऑन साइट एक है उसमें का। कल तूने फोन लगाया था दोपहर में, उसके बाद अमेजोन का आया एक वाला। चलो, सुबहदीप ने लगाया फोन तो कॉल भी आते हैं।
Hello.
हेलो।
Yes. So Nitesh and Vasant still not here, and we are meeting after almost a week, I guess.
यस।
Yes. How was your interview, Athar? So you gave so many interviews.
या अच्छे चल रहे, अभी तक एक भी रिजेक्शन तो नहीं आया है। एवरीथिंग इज गुड।
सही है।
या
Rejection नहीं है, but what about selection?
ऑन साइट आया है दो, बाकी लोगों के अभी ईमेल आने के।
Okay.
बट दे यूजुअली टेक ऑलमोस्ट लाइक 3-4 days टू लेट मी नो।
Okay. So Pradeep, you have sent me a code for this iterative pre-order.
यस सर।
We have been planning this tree traversal for such a long time. I guess you people have read a lot of traversal then. Should I be doing
यस,
traversal or not then?
आई
करना
थिंक
भी
वी
चाहिए नहीं?
नहीं करना चाहिए,
नहीं क्यों चाहिए?
अनलेस अनलेस बहुत अच्छी टेक्निक कुछ पता है।
बहुत
जब
अच्छा
मैं
कुछ।
भी देख रहा था, एक स्टैक, वन स्टैक, टू स्टैक, ये सब करके देख रहा था।
Yes, using a queue, using stack or like
वर्टिकल ऑर्डर कर सकते हैं, वर्टिकल ऑर्डर नहीं किया हुआ।
vertical order कर लेते हैं। चलो ठीक है।
और अगर पोस्ट ऑर्डर का कुछ अच्छा पता होगा, बिकॉज आई थिंक पोस्ट ऑर्डर थोड़ा हार्ड भी है और सबसे ज्यादा पूछा हुआ क्वेश्चन भी हो।
Post order
ट्रैवर्सल
without
विदाउट
post order.
रिफ्लेक्शन।
Okay. इन दोनों ग्रुप में कहाँ आ रहे आर दे joining or not?
यस। अरे क्या चेंज हुआ?
अरे यार सर गलत दे दिया।
गलत दिया ये?
हम्म
ओ ओ यस है। एक मिनट, तूने भेज दिया ना?
ये पुराना वाला है। प्रवीण,
हम्म
हम लोग अभी तक जो जो कवर किए ना लाइक स्ट्रिंग लिंक लिस्ट, ठीक है, तो उसका अगर आप मतलब आपके हिसाब से जो जो क्वेश्चन करना चाहिए वो अगर लिख दे तो सही रहेगा। मतलब डिफरेंट टेक्निक, मतलब वो पांचों क्वेश्चन अगर है तो पांचों क्वेश्चन से बहुत सारे क्वेश्चन कवर हो सकते हैं।
आई डिडंट गेट एक बार फिर से रिपीट कैन यू रिपीट
मतलब एरे स्ट्रिंग और लिंक लिस्ट भी कवर्ड, करेक्ट? सो
अरे
कैन यू
लिंक लिस्ट एंड
स्ट्रिंग
पुलिस हाँ हाँ
we covered, correct? So can you provide a list of questions for
हाँ
those topics? Like वो तीनों, like for linguist, you will provide three questions, okay?
हाँ हाँ
For three different techniques, and using that three techniques, you can cover lots of questions.
ओके using that technique you can solve lots of questions but I
मतलब
don't know
बेसिकली वो क्वेश्चन करके जाओ तो बाकी कर सकते हैं।
I understand what you're asking but there is no special pattern like this ऐसा है नहीं कि मतलब तीन क्वेश्चन के टाइप के सारे क्वेश्चन ऐसा है नहीं uh,
Failures for different
you might get little bit so जैसे even this all these traversals uh, the common thing between them is understanding that using a stack what can be achieved using a queue what can be achieved but if you want to call them a single pattern question you can I am not uh, I won't even say that this is also a similar pattern question even this finding sorry pre-order without recursion post order without recursion all these things even these are similar questions but the answer might not be the solution might not be the same pattern the question is obviously similar so my point is itna aasan nahi hoga ki I'll be able to give you 3-4 questions each topic and rest of all the question would be similar
तो
I will try मैं थोड़ा try करूंगा can I try to cover all the cases in few questions rather than randomly trying question I can try but that will take some time if you give me I start tomorrow एक week लग जाएगा मुझे सारे इस तरह का pattern तैयार करने में so I'll start doing that but it won't be that simple for me to create for you to understand also कि हाँ ये सब cover हो रहे हैं ठीक है
मतलब मेरा पॉइंट है कि कोई क्वेश्चन, मतलब कोई इंटरव्यू जाने से पहले
हाँ
तो वो हम लोग रिवीजन कर सके।
वो हम क्या कर सकते हैं रिवाइज
रिवीजन, हाँ।
हाँ तो what are the questions I have been doing we have been doing in the class is you have to make a collection of that only just make a collection of that and with solution without solution and then go through without solution if you're stuck in that then switch to the one with the solution I mean you have to create your own library if you want me to create that thought I'm like but what a question we do you should have been doing this key create your library of question if you go through my github I'll share you so I have two libraries I used to prepare that when I used to give interviews all the questions. So I will share that by hand, but that is not very intuitive for you to understand. That's my language of story, and I have one more library from where I ask questions in my GitHub. You can, I think you can see the public folder. तो वो मैंने बहुत पहले बनाया था, like 2-3 years ago. So you can create your own set of questions whenever you go through, especially the class questions, as well as your separate some library. If you want me to that will be very standard. वो थोड़ा time लगेगा, not even 1 week. It will take me more than 1 week. So I'll keep on preparing from every topic that I have taught. I'll be teaching. ठीक है?
Okay.
Okay. So and there are four of you. You can do that, share that load among yourself. You all can just try to create a common doc. We have a common doc, or you can create another doc, or you can share questions from the WhatsApp group. WhatsApp group won't be that good. So create a doc, and then you all can keep on pasting questions. Like, I'm solving this question, and this will go to our library of questions. बहुत library बन जाएंगे. Yeah, I will coordinate. I will try to help you. So what I will do is in the shared doc, or some other shared, the good way to say, like, which is where we can be live every time. Google Doc हम live नहीं रहते हैं. I'll think of some other way. So जहाँ पे we can share questions, and along with the grouping of questions. This is a group of string questions. This is a group of tree questions. Let me think of some solution. So that library you want me to build, it can be built by sharing only. मैं खुद से बनाऊंगा तो बहुत ही ज़्यादा नहीं बनेगा. तो ठीक है. I'll try to think of something how to create this library of question which you can just go through before an interview, so that your mind is fresh. At least जो question तुमने कर रखा है during the class, during discussion, वो उसमें miss नहीं होगा at least. ठीक है?
Yes.
Okay. So all of us are here, and what we'll do is we'll start with. So we will be, yes. Anyone? Yeah. So we'll be doing some tree traversals today. I thought we would cover lots of tree traversals, but since you people are already done a lot of tree traversal yourself, I'll just go through very fast, and then we'll do some difficult ones, not the easier ones. So we all know, and if just stop me if you do not know what I'm saying. Okay, if you do not know pre-order, post-order, these words, if you do not know any simple algorithms, just stop me. I'll assume you know. That's why I'll move fast. So basically, when we learned about traversals, we just talk about 3 types of traversals. The basic ones are pre-order traversals, post-order traversal, and in-order traversal. I hope all of you know this word, and you also know the pseudocode. You all know the simple recursion code for all 3 of them. As the word says, pre, post, in. So pre is you first visit the node, do whatever you want to do on the node, and then recursively call on the left node and the right node. That is what pre-order traversal means. So if we do not do anything, just try to print it, the order in which it will be printed, that order is called pre-order. Next, post-order traversal is first call recursively on the left node, then call recursively on the right node, and then you visit the node. So that is called post-order. And if you just try to print while traversing, the order which will be printed is the post order, and in order is as the word says. So we first call recursively on the left, and then we visit the node, and we call recursively on the right node, right child. So that is simple pre-order, post-order, and in order. You all know the recursive code. Anyone here who has never seen recursive code for all these 3? All of you can write. So do one thing, just all of you take any one of them and write fast in the chat the code for either of them, like not either, but code for any three of them. Just write pseudo code for it, and you should be writing only 3 lines of code. Jaldi se likh do, and then I'll go ahead. All 4 of you.
Which one we need to write? Which order?
Anyone who can write, any out of 3, any one of them. ठीक है?
I've done pre-order in the WhatsApp group.
Okay. Atharu, you have written for pre-order, and that is, let me just paste everyone's code. So what I have written is for in order, and I hope this is one of the best pseudocode. So this is pre-order with what Athar has written. If root equal to null, then return. Otherwise, print the node data and then call equal to done. This is correct. So everyone is post order. First print the post order. Why print post order? The first printing the post order and then printing the right, and then print this. Correct. So this is also correct. Okay. You all know this. Now let's move ahead. And the next part of the, there's some more submissions. Just a minute. Yes, so whatever you have done, Vasant, hopefully that is also correct. If root equal to null, return node dot left. What is this? Node dot left. Vasant, whatever you written is something very not so. I'm not understanding what you're writing. I'm just correcting that your thing. Okay, you have to call recursively. I don't know what you're trying to do. Okay, Vasant?
Yes, yeah, I forgot to do that. Yes.
No. Let's move ahead. So this is the tree traversal. Let me draw a tree. Let's draw a tree and then discuss slightly more. I hope you must be knowing only. So we have this tree. So what do we know about in order? What is the special thing about in order?
Left, root, and right.
So in order traversal of a tree, in order traversal of BST will give you all the nodes in a sorted order. So this is also one of the solutions. Sometimes when someone can you sort the tree and something like that, you just say, okay, I'll do the in order traversal and we'll get it sorted. So
just for BST, right? Not for BT.
Not for BTS. So what will be the, let's write all the traversal fast. People ping me all the traversal pre-portion in order. I want to discuss if we just have the traversal, can we determine the tree? So pre-order traversal of this would be 5, 3, 1, 4, 5, 3, 1, 4, 8, 6, 10. Post would be this is in order, I guess, and post would be 1, 4, 3, 6, 10, 8. Correct? All these are correct? So now just given one of the traversal pre-order, can we determine the tree? Suppose I have given you the pre-order traversal of a tree. Can we determine the tree? Can we draw the tree? Is it possible? Anyone? So the question is, Just given the traversal, can we determine the tree? Hello.
Hello.
Yeah. So
Yeah, we can find out root for using pre-tree because the first element is root here.
we can find the root. Okay. This will be the root. Then
Root. This
so
is not BST, right? This is just a binary tree.
it's just a binary tree. Yes.
Okay, so 3, 4.
So question is, given a pre-order traversal of a tree, can we draw the tree? Can we determine what the tree was? Nitesh, anything?
Yes.
What?
All traversals will be given or only one traversal?
I'm saying only pre-order has been given.
Okay.
So before you, what are you doing? What are you thinking?
No, it looks like it is not possible. I think which tree we can.
Yes. So just prove it if possible. Otherwise, I'll prove it. कि नहीं होता ये.
We can try. We can try with the root.
हाँ.
The
So we have
5 is root and 3 is less than 5, so we can put it in the left. And
It is
then
not.
the one
It's not a BST.
It's not necessarily a BST.
then not possible.
चलो ठीक है. So yeah, it's not possible. We cannot determine the tree given just by having the pre-order, or even if we just have the post order, or we just have the in order. With only one traversal, we cannot determine the tree. So let's take the case of pre-order only. We know that 5 is the root. We can determine easily, but after that, whether 3 is the left subtree or right subtree, it is ambiguous. Like we cannot decide. That's not ambiguous, but it is more than one tree can have same pre-order. So and with this example, let's try to draw 2 tree who will have the same pre-order. So this the one tree already drawn. Let's try one more tree. इसका यही pre-order होगा. So 5 and then let's suppose we have this node at 3 only. Now we can draw one more tree from here completely, and then pre-order of this. Okay, we can draw the tree like this, and pre-order of this will also be equal to this only. So we have proved here that given the pre-order, we cannot determine the tree because there are multiple trees whose pre-order will be same. Okay, everyone?
Yeah.
Yes.
Yeah. Yes, nice. So now you think about.
Praveen, can you come again? This one 5314. Can you come again? I did.
So this tree which I have drawn, I'll let me complete this 4 and then 4 having child as. Just give me a second. Can I move this? Yes. Yeah. So this tree, 4 and then 4 has 2 children. One is 8 and one is 6 and one more children 10. So what is the pre-order of this yellow tree which I've drawn?
It will be the same as the left one.
Vasant?
Can you come again? What's your question?
So what is the pre-order of this yellow tree?
Not similar.
5
Yes.
and 3.
Yes.
1.
Yes.
4.
So it is going to be exactly same. So two different tree have same pre-order. Hence, and not just two. There will be we can draw multiple other trees which will have the same. Hence, it's proved that we given a pre-order traversal, we cannot determine what the tree was. Okay, correct?
Means this right side, what is the type of tree this is? The right side, whatever you drawn.
This is a binary tree. Not possible?
So you mean to say that we cannot identify which tree it is, like whether it is a BST or binary tree?
This is a binary tree. What is the problem? This is a binary tree. We can see
Means,
easily.
what is the question here? Like, means by giving pre-order, what we need to find out?
Okay. So given the pre-order traversal, you have to draw the tree, like which is the root node, which is the left child of the root, which is the right child of the root, and then which is the left grandchild. That thing you have to determine. Given this array, this string, you have to tell me what is the root. You can say, yeah, given this is the pre-order, 5 was the root, so easy to say. But after that, we cannot say whether 3 was left child of the tree or 3 was right child of the tree, because both of them can result in same pre-order. So the question is, given the traversal, given the order of the nodes, pre-order of the nodes, we cannot tell which tree generated this. It could have generated by this tree, and it could have been generated by this tree also. So that's what the question. Okay. Now with this, I'm adding the given pre-order as well as in order. Both has been given. Can we determine the tree? Given this and this pre-order and in order, can we determine the tree? What the tree is using these?
Now it's possible.
Yes.
Okay. What will the algorithm be now? Can someone try to? If someone knows, good. Otherwise, try to think and tell me how will you do that? Suppose.
I don't know the solution, but I can explain what I'm thinking.
Yes, tell me.
So we know from pre-order the root, that is 5.
Yeah.
So
Okay.
if we traverse in order, we will see 5 there, and the numbers before 5 will be on the left tree, and numbers after the 5 will be on the right tree.
Okay.
And
You are again following what he's saying, what I have said. So we will start with the pre-order. We know 5 is the root, and after we have found, we will try to find 5 in this pre-order, in order. Wherever 5 is, all the nodes to the left will go into the left subtree of the root, and all the node to the right of that 5 will go to the right subtree of the node, right subtree of the root 5. So what he's saying is, with the given these two traversal, we know, okay, first we see pre-order. Okay, so seeing the pre-order, we can say that 5, just a second, is the root node for sure, because 5 is the first element in the pre-order, hence this is root node. Now we do not know what is left and right, but we can say from the in order that all the nodes on the left, these 4 will be left in the left side. 1, 3, and 4 will be on the left side, and we can say from this pre-order that 6, 8, and 10 will be on the right side. This we can say from the, because this is in order. Okay, everyone? Yes. So now if you simply see that this seems to be a recursive method where we have taken decision about 5. Now what remains is a smaller problem of 1, 3, 4, smaller subproblem of 6, 8, 10. 6, 8, 10 is also in order. 1, 3, 4 is also in order. And there is another subproblem from 3, 1 to 4. This is these two new problem, and this 16 is a new problem.
So again 3 will be the root.
Yes.
And
again,
before left side of 3 will be 1, and right side of 3 will be 4.
Yes.
The same thing will happen on the right side. 8 will be root and 6.
Same thing will do on the remaining. So now with this, whatever you just said, can you try to write? So everyone followed this, what we did. Can you try to write the recursive code for this? Given array given array in you have to write a code which will generate the tree.
So this pre-order and in-order is given as an array, right?
Yeah, array of integers has been given, and
Okay.
let me try to write. You can start writing. Meanwhile, I'll start write the signature of the message. Everything. Okay. Anyone have any question? Otherwise, you'll have to start writing. No question? Start writing then. This is all the classes signature needed for you to implement this code.
So root equals to pre of 0, basically.
Root equal to pre of 0. Yes. I mean, root
Yeah.
is equal to yes.
Then we will write a for loop till in order.
Tell me what to write.
Maybe root equals to, let's take a node, root pre of 0. Yeah. Then now the second thing we have to do is find that number, that node in order. So basically we will traverse through in order to find that number.
Okay. Before I do that, I'll just try to make it like simple for you so that you can think. Let's have maintain indexes. Okay. So this is a method node create tree which takes pre-order, post-order, pre-order and in-order, and then also takes the indexes just to maintain what part of the array we're talking about. Yes. Now what we'll do? So instead of pre of 0, we'll talk about pre of start.
Yeah, start pre.
Okay. Now what?
So write a for loop for till the length of in order I equals to 0.
For I equal to start of
start.
in.
Yeah. Till I less than length of in, or yeah, end of in.
Okay.
Now we have to check for this root node. If root equals to or if root, basically, if we found that root.
No, not root, but the value of the root, which is this.
Yeah, value of the root.
Everyone is following. Stop me if you're not getting.
If that is the case, we will make it as root then. No, but we don't have to, right? We have to just traverse it now on the left side and right side. So फिर से एक बार रिकर्सिव कॉल करेंगे और उसका जो इंडेक्स रहेगा इंडेक्स चेंज कर देंगे. Like start will be the same, but end will be before that middle element. So start will be same. Then end.
Correct?
Yeah,
Yes.
in order.
This one is the left one, correct?
This is left. ऐसा क्यों कर रहे हैं? In order, start plus one. Cool.
So you want to call recursively this time.
But
You can be on the this is other things. Sorry. So this will return left subtree.
yeah,
Left subtree is equal to create tree for the pre and in order, and this we'll have to pass this in the pre-order. We'll take the we start from where to where.
start तो सही है, I think. End in order का तो पता है, right? In order तो start करेंगे और n minus I minus sorry I divided by 2 तक.
Yeah. So we'll talk about it. End will be in order में भी in order
Start ही रहेगा. End जो रहेगा that will be अभी जो element मिला है उसका index -1. That is I -1 basically. Right.
yes. What will the end of this?
Can you scroll up? Can we see the tree? Like, tree का वो जो array है, हाँ थोड़ा ऊपर. Yes. So अभी pre-order 1 3 4 तक.
Praveen,
Hmm.
one quick question.
Hmm.
We have to create a tree. That means we need to print it, right?
Why do you say you?
Or we should have a like tree.
What?
No, got it.
Okay, so I have written this. What will the so for this first recursive call? This is the start pre from start pre till start pre plus I minus start in. And मैं क्या किया मैंने? So for the recursive call, we have to take we have to call recursively on from 3 to 4. This is 3, 1, and 4. So 3 to ठीक है. 3 is not start pre, but start pre plus 1. So लेके start pre plus 1 to I minus start in, and this one will be in order on the from start in 1. Yeah, correct. So do you understand what ये क्या है? So size, there's a size. I start to I minus 1. This is start to I minus 1. ये था ना? So I just start I minus start of the in order will that is what I've added here.
I minus
Right?
start.
I minus start. What is so the what the this is easy. What will the new index for this part?
Right.
Okay. So in order we'll start from start in only, but from I till I minus 1. So what is the number of elements? What is the number of elements? This is the number of elements in the in order subarray which we want to find a tree. So this is the size from start into I minus 1. So what is the size? I minus 1 minus start. I minus 1 minus start. So this is the size of the array, and this is the start from where we want to start. So that's why the end index is equal to this only.
Okay.
Confusion? Shall I make it simpler for you, or you understanding what we have done? Vasant, समझ में आया?
Can you come again when it's like
Okay. So yeah. So what we have to do is when we call for the recursively for the both the left subtree and right subtree to create the left subtree and right subtree, we want to pass it the left part of the pre-order and like this part of the pre-order and this part of the in order. We want to pass this recursion. So that's what we have to calculate what indexes will go. So new start in pre-order and new end in pre-order. What will these be? Similarly, what will be the new start of in order and new end of pre in order? All these four things we have to calculate. So what will be the new start index for in order? So whatever. So for this left part, so suppose this was I. This is the where I found my 5. So all this we want to call recursively for this part. This part will be, we won't change, the start won't change, hence start in. Okay, this won't change. We are going to call it again on the from the same start. So this won't change. What will the new end? It will be I minus 1. This is easy. Okay, correct. For recursive call,
Starting in the sense the first element one. That is the thing, right?
yeah, this is
Okay.
start in order.
Okay, end in obviously it is 4, so I minus 1. Okay.
Okay. So now we have these two. Now for pre-order, we want to do it for this part of the tree. 3, 1, and 4. What is this 3? Start will change a little bit. It will become it will just increment by 1. So start pre plus 1. And then what will be the new end pre? This is a little bit confusing. Okay, what is going to the from where to where? From 3 to what part will assume as this is going to be new pre-order. So that thing I have done that by calculating the size, because size of the in order is going to be I minus 1 minus start in. I minus 1 minus start in. This is the size of the tree, size of the array which is going to be passed recursively. So that will be the size here also. So now
I
if
think
you know the start, we can just do this plus and then plus I minus 1 minus start.
Praveen, I think that should be only I, क्योंकि हम
I,
लोग एंड एंड
yes,
एंड इन तक जा रहे हैं ना, तो I minus
yes,
1 की जरूरत ही नहीं है. I
okay, correct.
Yeah, and even in the left subtree, the end should be I minus start in.
ठीक है. Now I just pass these 4 as my new recursive call parameters. ठीक है, Vasant?
Yes.
Okay. Now similarly we'll do for right subtree. We'll clear the right subtree. You can write it yourself. Same something similar will have to be written. Not exactly the index will change, but we'll call recursively for the right part of this pre-order, and then we call it right part of the tree, and then left part remaining part of the pre-order also. So we have just have to change these indexes, and by doing this thing, we have two. We call recursively, and we have the output from these two recursion. Now these two recursion will be just root dot left. Why to do this complete here, and then root dot right, and then we just return root. Correct? Any confusion, anyone? If not, then what is the time complexity of this solution?
Praveen,
Yes.
can we do using only like using int start underscore in and int end underscore in, means using only these two signature parameters?
Using only what?
Only these last two parameters and that two arrays.
You might be able to reduce two of them, like end pre and end in, but you cannot do with just the array. You have to maintain some index. You can
only in start in or in end in means only in
what
order को देखेगा
what
only in order को देखेगा मतलब int start underscore in है int
only in order. If you want using, just maintain one index for in order, that's it.
two index start or end for in order
For in order, maintain two index, start and end. Just maintain start and end of the in order. I'm not sure, but what I can guarantee that you can do it with two indexes, which is start of pre and start of in. Something like that you can, or something like that you can maintain and we can do. But just with start of in and start end of in, I do not think we can do that.
okay
So we can get rid of these two extra variable end pre and end in, but सिर्फ उन दोनों से नहीं होगा, and two we will need for sure.
okay
I have
मतलब
commented,
start in
yeah, just with start in and start pre, these two we can do this because size पता होगा, we know कि half size will reduce to half, so the start index and then end index will be size by 2, something like that. The addition start plus n by 2. With that
But
calculation we can go ahead.
वही चीज के लिए हम लोग फॉर लूप लगा रहे हैं, राइट? टू
Which
फाइंड
this
आउट, हाँ टू फाइंड आउट कि कौन सा एलिमेंट, ith एलिमेंट फाइंड आउट करने के लिए बेसिकली.
yeah.
सो आई एलिमेंट अगर वहां पे k इक्वल्स टू i लिख दिया या कुछ कर दिया तो आई थिंक हो जाएगा, राइट? नहीं?
No, I don't understand again what you're trying to say.
सो हम लोग डिस्कस यही कर रहे थे कि इतने नए वेरिएबल्स लेने की जरूरत नहीं है, राइट?
Yes.
तो अगर जैसे ब्रेक करने के पहले अगर
No. By removing variables, we just give me a minute. I'll be back in 1 minute. Just,
Yeah.
you can discuss. I'll be back.
Yeah.
Yes. So we were discussing that can we get rid of so many variables, but my point is दो से कम में नहीं हो पाएगा. We'll need for 2 for sure because we need to maintain what part of the pre and what part of the in has to be passed recursively, and by how can we get rid of other two extra variables which you're talking about by maintaining size somewhere like pre dot size से start करेंगे and then we'll pass. No, I think 3 need जरूरत पड़ जाएगी कि we'll have to pass size in that case. अगर n नहीं pass करना तो size pass करना पड़ेगा और बार every time we call recursively we'll have to decrease the size n by 2 and by 4. That way we'll have to go ahead. Okay, so Subodh, if you think you want to do it with less, you can try, but this is what we, what we want to do is we might make it more simple to understand. We might make it more readable, and less. This is very clumsy, not so clean code. You can try writing a clean code. We can discuss that. So idea again, just the idea is we know we are taking the benefit that first node in a first element in the pre-order is going to be root. Whatever part you take, that is going to be root, and then we can divide what remaining part will go in the left subtree of the root and what remaining part will go in the right subtree of the root. That decision is being taken by finding that element in the in order, because we also know that in order the arrangement will be that way only, that 5 will be in the middle, the root will be in the middle of the left subtree and right subtree. So using these two benefits, we can determine our tree, and this is going to be unique. ऐसा नहीं है कि given these two, they can be multiple. The way we talked about pre-order, this is not a case here. With these two order given, there is only one tree possible, and hence we can determine the tree. ठीक है? So next part is you will have to do this. Can we?
Here, Praveen, the thing is, okay, what we are returning the return route.
Yes.
So we are going to say that okay, this is okay working like.
What? How are you going to say?
Like here, we are going to identify that what is the final conclusion we are doing here.
No, we are drawing
So
the
he's
tree.
looking for final output.
Final
Tree.
output just okay. Final output would be so we'll have the tree created. So we started from here. There was nothing in our structure. So we took 5 and then we created this. Which let me then start doing this. So we got this 5. So 5 will be the root for sure. We know this now. Now we had done this now. That's what this is. So now with this 5.
That is correct.
Tree
That one you've done. If you scroll down, finally we are returning the root.
Finally, we're getting the root of the tree. I'm returning the root means returning the tree. That's what the returning the head of the linked list means returning the linked list. Returning the root of the root means returning the tree. We have written the tree.
That means here we are returning 5.
No,
Here
the whole tree.
Here we are returning the node which contains 5, which is the root of the tree. Here we are returning node, not the integer.
Node means only one node, like the first node.
Only one first node you can call first node. The better way is the root node of the tree. How do you?
Okay.
If I ask you to represent the tree, how do you represent the tree? You just tell me the root node, and we can access all the elements of the tree. Now, so we return the root node of the tree. This is the root node I created. This is the root node I created from the first value, and I called recursively for the left subtree and right subtree, and these call would have been also returning the left subtrigger root and right subtrigger root. Those two roots of the left subtree and the right subtree, I'm just pointing it to them as the left side and right side. Once I pointed, I'm returning the root again. So the root which I created, I inserted the value, then I inserted the left right value, and then I inserted the right value. Then I just returned it. 3 steps.
Okay, here we need to means why you commented that root dot right.
That because I haven't entered correct these values. You have to calculate these values.
Okay, that means we need to write down for root dot right as well. Probably we need to send the path. Okay.
Yes. Okay.
Okay.
Now just take this as assignment. You have to write this code for post, order, and in order. Can we draw the tree? So you have to draw this tree. The answer is yes, we can draw. You just have to write the code. And the last question is, can we draw this? This you don't have to write the code. You just have to tell can we or not. Given pre-order and post-order, can we draw the tree? This is yes, we can draw. Okay? Just assignment, these two assignment. We'll move ahead. Okay?
Praveen, one question.
Yes.
जैसे pre-order only if pre-order is given,
Yes.
you the construct of tree.
Come again.
Only if pre-order is given, then we can't construct the binary tree.
We cannot construct the binary tree only if pre-order is given. Yes.
Yeah. दूसरा traversal के लिए भी ऐसा है क्या? Like post order, in order. We can't construct. Only post order is given.
Yes, I got your question. You try to be a little bit clear at the last two words. Okay. Anyways, so your question is, given an in-order tree, can we determine the tree? So you try to answer this question. You think and tell me. Given only the in-order traversal, can we draw the tree? Or
No,
given
we
only
cannot.
given only the post order, can we draw the tree? No, we cannot.
We will not be able to find the root.
So everyone, if you agree, if someone hasn't been able to try to think why we cannot draw tree only with one of the order given. only pre-order given, or only post-order given, or only in-order given. We cannot draw the tree. That is for sure. How can we answer for all of them? So if you try to think, answer is we cannot draw. So if we try to think, see this tree, which all known is like this only, and tree which is so like this. So let me do. Oh sure. So this is a tree, and what is the in-order traversal of this tree? Can we say the in-order traversal will be 1, 2, 3, 4, 5?
Yes.
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 Yes. So now this is in order. Now suppose I try to bend this tree, something like I'm calling this bending. 3 is here, and 2 comes here, and 1 comes here. Okay. Now with this, this 1 and 2 is deleted. This is gone. So this also tree, this tree also will have the same in order. Hagening. So there are multiple ways to just tweak the tree little bit, but the order won't change. Not just the pre-order, but not just the in-order, but any other order. We can just change the tree little bit, and still the order will be maintained. Like this example, I had one very different tree. I just changed it completely. Still the in-order is same. So we can do the same thing for in-order and post-order as well. That there's a tree whose pre-order has we can see. And then can someone give me example of this? So my question is, suppose there is a tree whose pre-order is we can see, and just change the tree, so even that and so that the pre-order should not change. Let's try to draw the tree. So I draw this tree first. So for example, what I've done is I have drawn a tree for you, whose in order we can see easily 1, 2, 3, 4, 5, and then I've changed the tree completely. Still the in order was maintained. Now I have to draw example for you, or you have to tell me example where I have a tree and I change the tree a little bit. Still the in order the pre-order hasn't changed. Pre-order won't change. That kind of example we have to give. So let's try to draw a tree. This tree, 3, 4 and 5. What is the pre-order of this tree? 3, 4, 5. Okay?
Yeah.
Correct? Yeah. So 3, 4, 5 is the pre-order. Can we change the pre-order of this tree? Can we change this tree a little bit, and still the pre-order would be same? What if I make this? What is the pre-order now? 3, 4, 5?
Same.
Same way. So what I'm trying to prove is there is just small change and sorry, very big. We do a lot of change, and still I can get the same tree. Hence, given only one order, I cannot determine the tree, be it in order, pre-order, post-order. Okay?
Okay.
Yeah. Move ahead. Let's move ahead. So these are 2 assignments for you. One, write the code for this, and second, prove whether can we or not, or can we not find the tree, construct the tree. Okay. Next is.
But usually, by giving only, but as per your knowledge, but as per reality, by giving only one order, we cannot find out. That is a reality, right?
Yeah, given only one of the order we cannot find. So what is the problem? I've given you both. This has 2, post and in. So yes, we can find. This is pre-order and post-order both. Can we find or not? What is the problem here?
No, just I'm asking. You ask us to prove it right by taking only one order. So that's all.
Yeah. So I asked you to prove and what I tried to give you proof by example a little bit. You see, there is a tree whose pre-order is this, but I can change the tree completely, and still that pre-order will maintain, or in order will maintain. So that is the proof I was trying to give. That with only one traversal we cannot construct the tree. That's a thumb rule, and we can prove that. Done. Okay. Moving ahead. Now will not spend time, but we'll try to do this because this was very common. And although Athar and Sodeep has done this, but let's try to understand a little bit from like some try to understand a little more clearly what is happening so that you don't forget this ever. What is the question? The question is find the in-order traversal, pre-order traversal, post-order traversal, all three of them without recursion. So all this method which we wrote, this was recursion. Everywhere we were using recursion. So we had to write without recursion. So can we do pre-order? So people try to, whoever has done this, try with post order. Who are not done, try for pre order. ठीक है, जिसने पहले किया हुआ है वो post order try to write post order, and who has written it earlier not written try to do pre order without recursion. So just to give you help, कि without recursion means iteration for sure, plus hint is you can use stack or queue, something like that. Just and for similarly people who want to try, who has written pre-order, they can try post order traversal without recursion, and you can use either stack or queue, whatever you want. Okay, so right now it's 10:37. I'll be back by 10:41. 3 minutes for you guys. Okay. Athar, try post order now.
Praveen, please check on the WhatsApp group.
Okay, I'll check there. Okay. So if anyone is there who has anyone want more time, or shall I start discussing? Okay, I'm discussing then. So first we'll discuss the easier one, the pre-order traversal, and then we'll come to the. I think most of you are able to think about the pre-order traversal without recursion. Anyone who is not been able to do this pre-order traversal without recursion? Vasant, were you able to do it? Vasant,
Yes, Praveen.
yeah.
Yes,
So,
Praveen.
so are you able to do this pre-order traversal without recursion?
Yes.
Okay. Okay. So the idea here is we know we want to do the pre-order and we want to just so get the nodes, visit the node first, and then we want the left and the right. So what people have used stack or queue? What people have used for this?
Stack.
Stack.
All of you have used stack for doing pre-order.
Yeah. Pre, post, and in order stack, and for level order queue.
Okay. So you are. Let me copy your pre-order as well. So this is your pre-order code. You start from the root, and if this is null, you create a new code, new stack, and then you check.
We basically push and print the data and go to the left until root is not equals to null. Once we find the root equals to null, we will pop from the stack and we will go to the top of the right. Like whatever it's on the top, we'll go to the right.
Let me just see once. So if root equal to not equal to null,
जब
this
तक
was.
रूट नल नहीं है तब तक हम पुश करेंगे स्टैक में रूट को और जैसे पुश करेंगे वैसे हमको प्री ऑर्डर चाहिए तो हम प्रिंट भी करवा देंगे उसे एंड देन विल गो टू द लेफ्ट विल कीप गोइंग टू लेफ्ट अंटिल वी फाइंड द लास्ट एलिमेंट दैट इज जब रूट इक्वल्स टू नल नहीं हो जाता है तब तक.
Okay, just give me a minute. Let me try to understand.
Yeah.
True if root is not equal to null. Where are you? You are coming
ब्रेक
out.
ब्रेक कंडीशन इफ स्टैक जब एम्प्टी हो जाएगा तब एल्स कंडीशन में. पर यहाँ पे तो पहले इसमें ही मिल जाएगा राइट.
हाँ तो फिर पहले ही पुश कर देते.
ओके.
So while stack is not empty, we want to do something. This is correct, and that's why I pushed root first. Okay. Up.
Yeah.
This code will change a little bit then. So we have one thing pushed in our stack, and what you simply do, whatever is on the top of the whatever is at the top of the stack, that is, let's print this. Okay, like visit, like not just call it visit. Pseudo code we are writing. So we will visit s dot top, and once we have visited, we have to do some insertion into our again pop the left and right child of this tree into the stack now. So s dot push. Let's just pop only s dot push node dot right and s dot push node dot left. Is this correct? Is it correct?
Yes, correct.
sir?
Why we need to push right element first? Yeah.
Yeah,
Because
right.
from stack will pull from back, right, and ulta.
Yeah, last element we will.
We want to see the left first when we are
Because
popping out from the stack.
in pre-order, we first visit the node and then we visit the left node and
So
then we visit the right node. So we want to visit left first. For us to visit left, who's that first?
Okay, yeah, I got it. Yeah, I was confused. Yeah, first
I
right
think
and then left. Yeah.
the only thing is missing. We need to check whether that is null or not. Only if it is not null, then only we have to push that right or left. Otherwise, we don't have to null. Yeah. Yeah.
This was easy. Uh,
Yes.
you have read this good enough. Now, even if you haven't read this, you should be thinking in terms of now you should be able to relate your stack and recursion, because stack and recursion are something very closely related. Even if you are not using a stack, even if you are using a recursion, the code at the background it is using a stack to implement your recursion, by the way. So you should be able to think closely every time about a stack and a recursion. So what is happening here is you are pushing something into the stack so that you can pull it back. So that is what happened in recursion also automatically. You don't see that happening. It actually happens in the stack in a recursion. So what do we do in a recursion in a pre-order? We first visit the node. So that's what I've done here. I first visit the node and then I try to push what I wanted to visit next. But I try to push that late in the second. Sorry. I first pushed right node and then I pushed left node. So sorry. What I want to tell here is we want to achieve that recursion thing somehow, and to achieve that recursion, how can we think that how can we use the stack to achieve the recursion? That is what we want to think here. So let me write the pre-order here so that we can closely think. So pre-order, when we do in a recursion, we first visit and then we call pre-order. Yes. So this is a recursive pre-order and this is an iterative pre-order using a stack. So we first visited. See, and there is one more term, by the way, this pre-order, and then let me draw a post order for you. Now that we are discussing a little bit of recursion. So it's something called tail recursion and a normal recursion. There's something called tail recursion and normal recursion. So this is normal recursion. There's something called tail recursion. What that does, what the difference between tail recursion and normal recursion is. So this recursion is a normal recursion where we first do what we want to do and then record recursively on later. The last part of the code is recursion. And this is a tail recursion where we first call the recursion and then based on the output of the recursion, we do something after that. So there are two kinds of recursion. This is like calling recursively in the last part of the program or the code or the method. And this is tail recursion where we first call recursively and then depending upon the value of these two or not depending on the values two, we then do whatever we want to do after the recursion. This is tail. These are two different kinds of recursion. Okay, most of the time whenever you write your recursion, you'll see this happening, that or not necessarily two times. You might call this recursion 3 times, 4 times, or even just single time. यहाँ पे ये binary tree है. This is a case where we calling recursively on the left part, sub part. So recursion doesn't only mean कि we'll call it twice or we'll call it only once. It just means we'll call it at least once the same method on a sub problem. So these are two recursion, tail recursion, pre-order and post-order, or simple recursion or tail recursion. Okay. Now coming back to this implementation of pre-order without recursion, if you try to relate, is there anything we can relate? Like how can we always think in terms of iteration and recursion. How can we change any solution from recursion to iteration or from iteration to recursion? Can we see this code and try to think? So what can we see from here and what can we conclude? So we first visit the node and then we call recursively. What when we call this recursively, we store where this was called and we call recursively the value into stack, and on top of the stack. So what happens is this is the environment which gets called. Okay, I'm not able to give a very good explanation how to easily go from one recursion to iteration. I'll try to read some theory about this, about how to just think in terms of iteration and recursion at the same time. How can we change any algorithm from iteration to recursion or recursion to iteration? Is there any standard way to think? But seeing this to code, I can see some pattern happening. Let's try to write this for order or in order, whichever is we want to implement. But there is a way. Sometime we can try to think our converting our solution from recursion to iteration. Don't try to do this in interview unnecessarily until unless asked. There are times when you would be happy to just answer. Okay, I know this recursion also. I know this. So there was a question. There's a question. If you remember, I had asked you guys, or not, I'm not sure. So just this reverse a linked list in chunks of k. That solution that thing can be done using recursion and iteration both. So that solution also will try to see how do we change a solution from recursion to iteration or vice versa. Okay, now we'll do that later. Now let's discuss the next part, which is a little bit difficult, and I think no one has, or Atharv has tried this. So this is his code. This is a code, Atharv?
Yeah, this is little bit different than general code, like what we see on internet.
This is post order traversal without recursion. So let's draw the tree first, and then we try to think what is happening and what do we want to achieve using stack or whatever we will be using. So first, let's talk about pre-order only. Forget about post-orders. So in pre-order, what was happening was, let me write something also. 5, 3. This is a tree, and coincidentally, this is also BST, but okay. So okay, I didn't intentionally, not coincidentally.
Yeah.
So this is a tree, and what will the pre-order be? This is 5 will be the first, and then we'll have 3, and then 1, and then 4, and then 10, and 8, and 11. Now, if you think about this pre-order, and suppose we have to implement that and the question was to implement pre-order without recursion. So and we know that we had to use a stack, so we can think a little bit. कि सबसे पहले अगर it was visible by the way, so सबसे पहले 5 उठाया, we took 5, and then we wanted to go to 3, but we don't want to do recursion, so we pushed that deeper into the stack, and then so that we pushed 10 deeper, Yeah, we first push 10 first, and then we push 3 on top of 10, so that 3 can be taken out first. Because what we're doing in this while loop is we just taking the topmost node out every time we in the loop. We just were doing that. So on similar line, we'll try to think about this. Is easy to understand, but now we're going to do this for our post order. That is how will we implement our to understand this code. You have to understand what is happening. So post order is first when we go to visit a node, we just call it recursively on these two, the children, and then every children we call recursively for this sub children. At the end, we will visit this. So we are starting from this our root. We are given the root, so we will call post order from here, and we will try to push everything in the stack which we want in the order we want to. It's like what is happening here also. So we want to push things into stack so that when we pop, we get in that order. That is what's happening here. One good way to say is we're pushing everything to stack. Well, we're pushing this into stack. We're pushing this into stack, and and while pushing, we are also popping. And what we want to ensure that we push in the proper order. That's what by ensuring that we push in proper order, the pop will be proper. By proper, or we mean we push in the reverse order, so that when we are popping, we get the order we want. That's what we are doing in the pre-order. Similarly, for post also, we'll do something like that. While visiting the nodes, or while going through the nodes in the code, we'll try to push the order in the reverse we want. Okay, so सबसे पहले हमें in our post order, what do you want? We want, what is the first element in post order? What is the first? One. So the way we want to do it, we want to push one into our reverse. No. So we want to push in the reverse order. सबसे reverse में डालना है हमें.
So we have to push this for last, I think.
Yes. Yes. So we have to push it some order in a stack. So this will be last one to go, so that we can pop it out first. That's what we want to achieve. Okay?
Yes.
This is clear. We want to push it in, or if a queue hota, so we wanted to push it into the first part. That there are two options. Either we do it queue or stack or something else. But we want to get rid of. Sorry, no, we want to get rid of recursion. Not get rid of recursion, but we want to change from recursion to iteration. So which simply means that we might have to go for a stack. So one simple thing to think about whether to use a stack or queue is, if you want to remove a recursion, you will have to use a stack. That is some thumb rule we can use. I don't know if we can use everywhere, but we can think. So now let's think, how can we do that? Can we do that? Can we just so what is going to, this is last 5 is the last element. 5 is the last element in the post order. Okay, so 5, if 5 को सबसे पहले डाल देते हैं, can we do that? Can we push 5 as the first one? I'm also thinking. मैं भी भूल गया, so let me think. So some
5 को ही पुश करेंगे ना पहले, तो जो 1390 लाइन नंबर में लिखा हुआ है, पुश रूट फर्स्ट.
1390. Yes.
Yeah.
So okay, I'm thinking. Let me think. So one way would be push 5 into the stack, and then we have 3 and 10. Okay. Can we do it with 2 stacks? Can you think of using 2 stacks and then try to implement?
Yes.
Yeah,
We can do with 2 stacks.
So we will first push into our S1, and then we will pop it out, because we want to get 5 at the bottom of the stack. So let's start with S1 dot push 5. So we have 5 in here. Now we try to
check.
pop it and try to push that into this, and then we push both of it into a 3 and 10. Yes, you saying something?
Yeah. So we'll check up to S1 is empty or not.
Yes, so let's try to write that part. While S1
Not empty.
is empty, we start from the root. Let's push S1 dot push root. So we have root into our S1, and we'll just pop. We'll simply pop node equal to S1
Pop.
dot pop, and let's try to push this into our
Output.
second stack S2 dot push. So this is the stack S2 is going to be our kind of output. This is
stack.
something like this we're trying to do. So S2 dot push equal to no. Now we have our S2 done. We will try to add more thing to our S1. S1 dot push
Current dot left.
Node left.
node dot left. Are you sure you want to push left first?
Yeah, first left. Then
Yeah, because we have another stack.
Mm-hmm.
So we'll push into that stack and then pop.
S1 dot push node dot right. Okay.
now it will happen until S1 is empty.
Until which is empty?
S1 is empty.
S1 is empty. This is then what is
If when S1 is empty, we'll just move pop out all the elements from stack and print it.
that is S2. Yes, S2 will do first. So the S2 is somehow we were just pushing into S2. By doing this, we'll at the end when our S1 is empty, S2 will be a kind of output. We'll just push one by one. So
मुझे अभी तक नहीं पता चला कि S2 का काम क्या है.
So we'll come to that. कि S2 काम क्या है? But see, what we're doing is we are taking the topmost element of the S1 and putting that into our S2, and then left node is going to. So let's come to try to discuss this. What is happening here? S1 we pushed 5. S1 में 5 चला गया, and then we try to start this while loop. While this is not empty, we try doing this for every till that point of time. So node is equal to S1 dot. We popped from S1 and we pushed that into our S2. So our S2 is we're collecting something into our S2. This is just getting collected. Nothing. We're not doing it. Yeah, and then we have our S1 dot push node dot left. So 3 chala gaya and 10. Now after that we'll again pop. So what will pop now? 5 will be 10 will be popped now. So now we'll call on 10. Do we really want to call on 10?
10 होगा तो उसके बाद 8 और 11 चला जाएगा.
Yes. So we had option of 3 and 10, and in post order we know that we call on this, then we call
पहले
on
left आएगा.
Yes, in post order पहले left आएगा. So
पहले
we want to...
पहले लेफ्ट आएगा क्योंकि हम लोग पुश कर रहे हैं S2 में. अगर हमको S2 में पुश ही नहीं करना है तो हम सीधा राइट ले सकते हैं S1 का, राइट.
So if you do not
अगर हम 2 स्टैक ले रहे हैं, एक एग्जांपल लेके अगर ड्रॉ कर रहे हैं तो एग्जैक्टली सेम ही वैल्यू आ रहे हैं, राइट. 5 हो जाएगा S1 में, S2 में भी 5 डाल रहे हैं. तो rather than S1 से फिर S2 में 10 डालने से अच्छा पहले 10 S1 में डाल दो, फिर S1 में 3 डालो, right?
But if you push, so come again, what do you want to do?
जैसे एक 2 स्टैक ड्रॉ करो. सो हम लोग क्या कर रहे हैं कि 2 स्टैक कर रहे हैं. दोनों में अब फर्स्ट में हमने 5 डाल दिया.
No, you want to use 2 stack or 1 stack?
नहीं, मैं ये जो चल रहा है अभी वो बोल रहा हूँ, उसका फायदा कुछ नहीं दिख रहा है मुझे. जैसे 5 डाल दिया S1 में, राइट.
ठीक है. So we have 5 here.
हाँ, फिर हमने S1 से पॉप कर दिया 5, S2 में डाल दिया.
Okay, 5 gone. 5 यहाँ आ गया.
हाँ, अब फिर हम लोग 10 डाल रहे हैं S1 में पहले.
Yes, so we're pushing 10 and then we're pushing 3.
3. हाँ, तो
and
उससे
then we are
हाँ
popping this 3 again.
हाँ
No, are we doing opposite?
नहीं नहीं, पहले 3 डाल रहे हैं, उसके बाद 10 डाल रहे हैं।
हाँ कुछ भी करो वो तो हाँ
नहीं, कुछ भी करो तो नहीं होगा।
अरे वो एक ही हो रहा है
नहीं
कोड एक
करके
लाइन
देखो, करके देखो।
एक लाइन ऊपर एक लाइन नीचे लिखना है बस
wait. So yes, we did this. Now we'll pop 10. So
हाँ
10 will go from here to
10 आ गया और 3 आ गया
10 आ गया। नहीं 3 नहीं आया, सिर्फ 10 आया है।
ओके
Now when we took out 10, we inserted 8 first and then 11.
ओके
Now again we are popping 11 आ गया and 11 was removed from here. 11 doesn't have a child, so 8 will come
I
here.
think
So
अब ये भी
8
चला
और 10 आ गया ठीक है
अभी
अब 3 का
1 और 3 भी चला गया
3 भी चला गया
और 1 और 4 आ गया।
First we'll push 1 and then we'll push 4. So again 4 will go.
उल्टा जाएगा 4 और 1। पहले 1 उसके बाद 4।
ठीक है? I'll not do a जगह नहीं मेरे ठीक है? So is this correct? Is it and then we just pop everything from here. So the order will be 1 4 3 1 4 3 8 11 10 5. This is correct post order. ठीक है everyone?
ठीक है
So let's try to see what happened once again. So we reached a node and we know that this should not be visited like although we have visited it first, this should have been visited last because this is a post order and I should not have been visited. So let's try to push it into S2 at the bottom of that. So I simply took it and pushed at the bottom of the S2. Okay, and then I got then I thought what should I do with the left child and right child, which one should I go first. So actually I want in a post order normally what happens is left is visited first and the right is visited. I mean we call recursive on the left part first and we call recursive on the right part after that. So we knew that should happen and that's why I popped left first and right second because they're going to be reversed in our S2 and then I want to reverse. I want left to be so left पहले यहाँ push करेंगे तो left वहाँ बाद में push होगा and hence left will be popped up. So there are 3 things. One is I popped first in S1, hence it will be pushed later into P2 and hence it will be popped again at the last later. Okay, 3 step है यहाँ पे. So the decision to push S1, the decision to push left into S1 was taken because if I push S1 first, this will be popped in last, which I want, because if I pop it last, I push it. That is becoming confusing. So 3 step. Let's try to repeat again. Just keep saying. So if we push out of the option was 3 and 10. Shall I push S1 में पहले 10 डाले या 3 डाले? S1 में पहले if I push 3 first, so it will go later into the S2. That is, if 3 go later into S2, it will come first into our final output, and that's what we want. We want 3 to come first. Hence, it will go first into S1 also. ठीक है?
पहले राइट प्रोसेस करेंगे तो एकदम बिगड़ जाएगा।
Yes.
आउटपुट होगा 2198765। कोई ट्रैवर्सल ही नहीं है।
Yes. So again, I'm repeating what we do normally in recursion is we first will call recursively on the left and then we call recursively on the 10. So and then only we visit whatever wherever we are. So that's why and we have maintained a S2. We have maintained a S2, which is actually the reverse order of the final order we want. This is the reverse of the final we want. This is storing this S2 is storing the output in kind of reverse order or the order we want. So सबसे पहले we went to 5 and we know from our knowledge that this is the node which should be last in the post order. So let's just push it to the bottommost of the S2. The moment I pushed, now the decision should actually what should come is 10 and 11. So that's why we have to decide whether 3 should go first in the left subtree, whether 3 should go into S1 first, or 10 should go into S1 first. This decision was taken based on which will be popped first and which will be pushed to S2 first. That is the decision we have to take, and simply we can call this for both the left and right. ठीक है? Of course, you have to check everything null and all those checks you have to add. Confused? Anyone who got it very easily, or people who are confused? Just tell me. I'll repeat once again.
Solution समझ गया, but I think better solution हो सकते हैं.
Better in the sense?
Like S1 और S2. So basically point is S2 हम क्यों यूज कर रहे हैं? क्योंकि हमें रिवर्स ऑर्डर में उसका पॉप करते समय हमें वैल्यूज चाहिए बेसिकली, राइट?
Yes. So you're saying you don't want to use S2, you can do it single.
हाँ, सिंगल लो या फिर क्यू ले लो, बेस्ट है. अगर रिवर्स ऑर्डर में ही चाहिए, राइट? तो रिवर्स ऑर्डर में लेना है तो फिर क्यू ले लो, एक ही क्यू में हो जाएगा. 2 स्टैक की क्या जरूरत है?
So you're saying this complete thing can be done with only single queue?
या ऐसा लग तो रहा है.
Because
so basically हम लोग S1 में जो कुछ इंसर्ट कर रहे हैं वो that is exact duplicate of S2, right?
Not exactly. No, नहीं. Duplicate is not duplicate of
हाँ, डुप्लीकेट ही है ना. हम जो S1 से लेके उसी में डाल रहे हैं, S2 में डाल रहे हैं बेसिकली एक वैल्यू. अगर हम सिर्फ S1 चला के देखें ना इस पे, तो भी वही आएगा, सिर्फ रिवर्स ऑर्डर में आएगा.
नहीं, wait. So it won't be there because first of all S2. Let me tell you one thing. So S2.
ये भेजता हूँ मैं WhatsApp पे.
ये
WhatsApp पे भेज रहा हूँ मैं ज्यादा क्लियर नहीं है, but I think something.
Listen. So what is happening here? S2 is not reverse of S1. Why? Because if you see S1, 5 was pushed and then 3 was pushed and 10 was pushed. But here if you see 5 and 10, there is no 3 nearby. 3 बिल्कुल ऊपर है. So S2 is not at all reverse of S1. It is everything we are popping from S1 and pushing it into S2, I understand, but not the same order in which it was inserted. This order first step में लगता है कि same. After that we have 2 elements, left and then we have right. We bring right, but we're not able to bring left at that moment, because the moment we bring right here, we add more elements to S1. So 3 अंदर ही फंस जाता है कहीं पे, 3 अंदर ही अटक जाता है. We just play with the rest of the part. So my point again, your point was S2 is somewhat reverse of S1. Is not.
नहीं, point is output जो आएगा that is reverse.
Reverse of what?
Let's say हम लोग 5 डाले थे S1 में, ठीक है, और हम पॉप कर देंगे. हमें स्टैक रहो या अरे रहो या जो कुछ रहो, हमें उसे निकाल देना है बेसिकली, आउट ऑफ स्टैक करना है, ठीक है? फ्रॉम S1 ही ओनली. सिर्फ अब सिर्फ S1 का चलेगा, ठीक है? S1 में हमने 5 डाल दिया, हमने उसको पॉप कर दिया,
ठीक है.
अब हमारा रूट जो है वो
वेट, लेट मी ड्रॉ फॉर यू. सब कुछ ड्रॉ करते हैं.
दो स्टैक लेने से आसान है सॉल्यूशन देखा जाए तो, पर ठीक है.
Okay, so I'm drawing one stack.
Yeah.
So we have pushed 5. So by the way, I not saying it cannot be done with only one stack, but yes, we are going to discuss that thing only. Next part of the question was this only. Can we do it with a single stack? So we have pushed 5. What next?
उसे पॉप कर दो. एक ही वैल्यू है, राइट, हमारे इसमें. हाँ, एक अरे में ले लो या कहीं भी ले लो, ठीक है?
ठीक है.
अब 5 का लेफ्ट और राइट देखना है. तो सबसे पहले लेफ्ट देखेंगे, दैट इज 3. सो अभी स्टैक में उसको 5 को क्रॉस कर दो और 3 डाल दो. 3 and 10 चले जाएगा अभी स्टैक में.
3 first and then 10.
हाँ, then 10, ठीक है. अब हमारा 10 हम पॉप कर देंगे, हमारे जैसे जो चल रहा है व्हाइल लूप बेसिकली, हम
Okay.
10 पॉप कर देंगे।
Okay.
अब हमारा रूट हो गया 10, तो 10 कहाँ, 10 निकल जाएगा और 8 और 11 आ जाएगा।
First it will be
8 एंड देन 11, लेफ्ट एंड राइट। फिर
okay.
हम 11 निकाल देंगे, वो तो फिर नल रहेगा, तो हम फिर 8 भी निकाल देंगे, रह गया 3। सो 11 एंड 3 पॉप कर दिए बेसिकली, क्योंकि उसका
11,
लेफ्ट एंड राइट तो नल।
11
हाँ,
and after that
8 भी कर देंगे, क्योंकि वो तो नल नल वैल्यूज है ना उसके लेफ्ट और राइट।
11 आगे वेट आगे then
हाँ, अब 3 पे आ गए। अब
okay.
3 का लेफ्ट और राइट डालेंगे, दैट इज 1 एंड 4। स्टैक में 11 और 8 निकल जाएगा और 1 और 4 ऐड हो जाएगा।
11 8 निकल गया, that is okay.
अब
But don't you want to extract 3 also? 3 वहीं रहेगा.
नहीं नहीं, 3 रहेगा। हाँ हाँ, 3 को एक्सट्रैक्ट करेंगे, राइट राइट, 3 को भी पॉप कर देंगे। और 3 रूट है, तो 3 का लेफ्ट जो है दैट इज 1 एंड 4।
So first we'll pop 3 or first we'll
एग्जैक्टली,
insert.
या
So
वी
first
विल पॉप 3, वी विल पॉप 3।
okay.
और अभी 1 और 4 आ जाएगा स्टैक में, एंड दैट इज 1 एंड 4, दैट इज द रिवर्स ऑफ 1 एंड 4 नहीं, 1 एंड 4 स्टैक में आएगा ना, तो 4 पहले पॉप होगा और फिर 1 पॉप होगा, दैट इज 4 एंड 1 आंसर में। हाँ, और इसका रिवर्स इज योर पोस्ट ऑर्डर।
So that's what we also did. Just that we
हाँ
how
बट
where you want to store this.
वही एक स्टैक लो या अरे लो, बट द सेम थिंग कैन बी डन इन क्यू ऑल्सो, राइट। और क्यू में आउटपुट कैसे मिलेगा, इसका रिवर्स ही मिलेगा ना डायरेक्ट। हम एग्जैक्ट सेम थिंग क्यू में कर सकते हैं, राइट।
Q में रिवर्स नहीं मिलेगा, Q में सेम ऑर्डर मिल जाएगा, 5 10 मिल जाएगा ना। If you start into Q, so if you insert this was kind of Q only ना, Q ही तो था ये। If it's into we want the reverse order, so reverse order करने के लिए कुछ सबसे simplest structure was stack only, तो just store into stack and then reverse. Otherwise if you store into Q, how will you reverse? Reverse करने के लिए क्या करोगे? If this was a Q, suppose this was a Q, what do you do now? So we have stored everything. We kept on doing Q.NQ5, Q.NQ10, Q.NQ11, Q.NQ8. So we kept on doing that. Now we have the queue of all the elements. Now what will you do? How will you get me the reverse order?
या अगेन उसे रिवर्स करना ही पड़ेगा। सो बेसिकली स्टैक इसीलिए कर रहे हैं हम लोग कि रिवर्स ऑर्डर में हमारा आना
हाँ
चाहिए, या तो फिर अरे में स्टोर करो और अरे को तुम रिवर्स ऑर्डर में प्रिंट करो।
Yes, traverse from the backside and then I mean
मतलब स्टोर करना ही पड़ेगा, नहीं तो
हाँ, कहीं ना कहीं स्टोर करना पड़ेगा बेसिकली, राइट। नहीं तो फिर वो रिवर्स ऑर्डर में ही रहेगा हर बार।
clear now everyone?
Yeah.
So now can we do it without using just by just using one stack? Can we do it using only one stack?
मेरा जो सोल्यूशन है वो एक है, वन स्टैक वाला ही है वो।
Okay, let's go through that then. This one? Okay,
ट्री
so what?
या ट्री रहने देना था, सो वी कैन गो थ्रू, लाइक ड्राई रन कर सकते हैं।
What is this tree? Tree node. Okay, we have this stack. We have pushed the root. Now until this is empty, we're doing this. We are creating getting one node equal to s dot top, and then if n of left is equal to null, and n of right is equal to null, both of them are null, then pop it out. That's it, pop. Otherwise, if left and right is not equal to null, then push s dot push. Okay. Let me so let's try to run your code into this. Yeah. So we have first pushed our 5.
Yes.
And then we have to run in this loop while this is not empty. And we check both of them are not null. So we ignore this. We go ahead. this null, this won't happen, and we'll run. Then if right is not null, then push
10.
10.
हाँ, और 10 के सामने एक null लगा दो because we are making it as null there.
What 10
हाँ,
null कहाँ है?
so basically 10 जो है stack में डाला हुआ,
Yes.
उसी को एक null बना रहे हैं हम लोग यहाँ पे. Basically we are making it as a visited node.
If n dot right is equal to null, not equal to null, then s dot push 9, and then n of right equal to this. इसको null बना दिया हमने.
हाँ.
Null. Okay, now what?
अब root जो है हमारा 10 ही था ना, 10 नहीं क्या था, 5 था, 5 का 3.
Yes, and then we did the same thing for our 3, and we made this null. What next?
Next गए,
We'll go above and we'll repeat the same thing into a while loop. While loop होगा ना?
हाँ, right. अब stack का top लिया n, that is 3. और फिर से हमने 3 का left और right देखा और दोनों को null कर दिया. So 3 का right आ जाएगा 4 और 1 और दोनों को null कर दिया.
Okay.
अब 1 का left और right देखेंगे, that is null. So basically 1 pop कर देंगे और 1 हम लिख देंगे, हमारे इसमें print करवा देंगे. 1 pop हो जाएगा basically.
Okay. Then we have popped this. This is if. These are all if or else if.
If both.
Okay. Then we check
So
n of.
हाँ, अभी हमारा stack में से 1 चले गया, right? अभी top 4 है. So basically 4 का भी right left देखेंगे और 4 print करवा देंगे, क्योंकि 4 का right left दोनों null है.
So we were here. यहाँ पे n equal to s dot top, and then we check n का right is null and n का left is null. So we popped p equal to s dot pop. So n and p will be same, na? In this case.
Yeah.
S dot. So we popped this, and then we just printed this. So one got printed, and then we checked n and right not equal to null. तो ये तो नहीं चलेगा, ये भी these two won't run, and they'll come again for 4.
4 का भी right left null रहेगा, तो pop कर देंगे और 4 print करवा देंगे.
हो गया, and then we
अब 3 पे आ गए.
Okay.
तो 3 का right और left null है क्या? है, क्योंकि हमने उसे अभी null बनाया था ना.
Yes.
तो दोनों null है, इसलिए हमने वो भी print करवा दिया और pop कर दिया.
Okay.
आप आ गए 10 पे, और 10 पे भी सेम एग्जैक्ट जैसे ये किया था कि 8 और 11 लेंगे, उसे नल बना देंगे और एग्जैक्ट सेम रेप्लिका रहेगा बेसिकली अभी जो लेफ्ट में हुआ वैसे.
Okay.
और फाइनली 5 प्रिंट हो जाएगा, क्योंकि 5 का भी राइट और लेफ्ट दोनों नल बना दिए हमने 3 और 10 को. 8, 11, 10 और 5.
Everyone.
बेसिकली विजिटेड वाला कंसेप्ट है, सिर्फ उसे नल बना रहे हैं और चेक कर रहे हैं.
Yes. Okay. Others. Vasant, Nitesh, समझ में आया?
Yeah, the visited null we are making as null, right? So yeah, that's right. Looks like.
Yes. To me, it looked like it will work. Let me try to think. Is there any problem? Just correct for all the cases, so he's doing it.
Praveen, can you come again one more time? Traversal, start from 5 and do it again if you are okay.
Okay.
See, first 5 we are inserting, we are pushing. After 5, next is right.
Yes. So we pushed 5 first. So this is the
Yes.
start of the method. We first pushed 5 and then we ran this while loop till this stack is not empty. And what it does, he checks if both the children are null, then pop.
Yes.
If the children are null, then pop. So 5 gets popped. Sorry,
No.
I mean,
Like
yeah,
it would
that's
get.
what it is. Yeah, so that's what, if both are null, then only pop. Otherwise, go ahead and if the right and then if right is not null, push that. If left is not null, push that. So he pushed right and left. So by the way, while pushing, so right was not null. So first he pushed 10, then got pushed, and then but when he pushed that, he made n dot right equal to null. This thing he changed it to null. Now because he has already reached this node, deleting this node is not a problem because he has already reached node 10. N dot right is not equal to null. He already pushed that into the stack, and n ka right he has already saved somewhere. That's why making n dot right and n right, equating it to null and using it for some other purpose is not an issue. Otherwise, losing that, this could have been a problem. But just because we stored that into a stack, it will be accessed some other times. We don't have a problem losing that also. So we store that and we just made this thing as null. By doing this thing as null, what we are one thing what we are achieving is whenever I reach this node again, I'll check if this is null. I'll do something, so I won't have to go deeper again. That's why I made this. So he has created this pointer and pointed to null. It will be used later when both of them are null. Pop it up. That's what he's trying to do. So similarly, he goes for the he does it for the left as well. So if n dot left not null, which is in this case here, first he will push 3, push left, and then he will again, because we have already pushed 3, we can delete this pointer, make it null. We can change this, and we have reached. We have these two in our stack. 10 and 3, both of them are in our stack. With this, and 5 is also there. And with these two links deleted, with these 2 pointers pointed to null. Now with this 3, 5, and 10, we'll start from 3 again, and then we'll do same thing for 3. 3 will push 4 because it's not null, and then we'll change this pointer again to null, and then 3 will push 1, and then after that in this pointer will also be point to null, and then we call it recursively for not recursively. Then we go and do it for 4 and 1. So for when we do it for, sorry, I think is it correct? 4 and 1. Now we are on 1. When we are on 1, we check both the children are null, already null. Okay, this both of them already null. In that case, we pop. So we have popped. And now while coming back, while retrieving back, only those will be popped whose both the children are null. So we already have 1 came out, 4 came out. Now 3 will also be popped because both of them are null. But okay, if everyone understood this, let me think now if will this work every time or not. Vasant, Samnaya?
Yes, Praveen.
Okay. So I'm just thinking, will this fail anywhere? 1, 4, 3. Okay, looks that it will work. I'll think of again later. We'll go ahead and do the next question. If anyone has any someone who has not understood, tell me. Someone who is able to find a problem with the solution, also tell me. Otherwise, I'll find a problem. I'll try to validate with whether this works for all cases or not.
Yeah, tell me one thing. Each node visits only one time, right?
Each nodes.
Means when we traverse, each node will be visited only one time.
Each node will be visited only once. So we visit, and then visited by visited you mean There
Like
are two. Yes.
first we traverse. Once we traverse, then each node means we are visiting only one time.
Yes.
While iterating means iterating also we are going from top. So that time we are checking. I think it looks like while popping out also we are visiting only one time. Means as usual that is always one time. But traversing also only one time we are visiting each node.
Hmm. Yes. So let's go ahead. I'll try to think more if if this is uh, going to work for all the case or not. Okay. We'll move ahead. Please. Okay. So next question uh, is there are multiple other traversals. We have just done 3 basic traversals. So we wanted to discuss the other similar level order. We will discuss reverse level order, and we can
Vertical order.
vertical order. Okay, let's first do vertical then, and then rest you can do at home or like after the class. Let's try to do vertical is a little bit not so easy. I mean, it's easy only that the code of these are very simple to write compared to vertical order. Let's try to which one? So let's try to do vertical then. So what is vertical order traversal is? So vertical order. This is a vertical order traversal of so this is 1, this is 0, this is 1, and this is again 1. So this is, these two are same vertically. Are they? This is one vertical order. This is same vertical order. These two, these all three. This is one vertical order. 1, 2, 3, 4, 5. So there are 4 verticals here. I mean, if we try to see, we have 4 vertical lines here, 5 vertical lines here. This is vertical line 0. This is vertical line 1. This is vertical line 2, 3, and 4, like 0 to 4. Total 5 vertical lines. And vertical order traversal means this is one. I mean, vertical order traversal just visit all them in first zeros vertical all the nodes present in vertical line 0, then all the nodes present in vertical line 1, then all the nodes. So if I try to write this, the order will be, let me rid of this. So with this order, the output of this vertical order tree will be first 1, and then 2, and then 3. No, after 2 we have 3, 4, 5 should come in single. So it will be 3, 4, 5 will come 3, 4, 5. 3, 4, 5, then 6, then 2. This is kind of vertical order traversal. So, everyone understood what is vertical order traversal. There are simpler traversal which we could have done, but this is one of the complicated little bit traversal of a tree in vertical order. So all the nodes in one vertical line is it will be the order will be first vertical line 0, vertical line 1, vertical line 2. So like this we will just do for all the vertical lines.
This the
And
middle vertical line is not clear.
Yes, I understand. So what? So if we start from the leftmost vertical line, which is 0, then all the nodes which is just one step right is 1. So suppose
Okay.
there was a child for 3 also, and that child was 2.5. Suppose in that case, 2 and 2.5 will be in vertical line 1.
Okay.
So it's like simple addition and multiple. Suppose we start with some vertical line x at the root. Then on the left node, then left node will be on x minus 1, and right will be on x plus 1. This is the vertical line. So and the leftmost will be 0. So if we again from this node, if you go on the right side, from this 4 to 2, this will be x minus 1, and again it will be pressed back to x. That's why this root and this 3 will be on the same line, same vertical line. So what vertical line changes by 1 for right child and left child. If the vertical line of root is x, then left child will be at x minus 1, and right child will be at x plus 1. This is the vertical line they will be part of. And if you try to print, so we have to get this order. Can we do this? So Vasant has to leave, but you can do this, and then I'll give you all the assignments. Let's just do this, and then we can leave. And after that, I'll just give you all the other traversal which you have to think. We'll do something else in next class. We won't do traversal. There are lots of other traversal, but we won't do in the next class. We'll do something else. So, okay, just try to think about this. How can you do this? So I want to do a simpler question before we do this tough question, so that you can think about this also. Let's just talk about height, the level or traversal. Give me a brute force and not the best one, because the brute force will make you easier to think about this height also. So give me a brute force approach to print the level or traversal of a tree. What is level or traversal? This is level 0, first this. This is level 1, then both the nodes in that order. This is level 3, all the nodes will come. This is next level, then this will come. So 1, 2, 3, 4, 5, 6, 7, 8. This is level or traversal. So how will you do a level or traversal of a tree? Give me any solution, not just brute force. Just tell me any solution for brute force approach. Try to tell me pseudocode, and then I'll try to relate that with our vertical order also.
The level order traversal, right?
Yes.
We can use Q.
Q. Okay. Yeah. So let's do it without Q. Let's try to do it without Q. Q is a smarter solution. Let's try to do it without Q. How will you do without Q?
Recursion.
Athar, why do you want to do recursion? First of all,
we can use Q.
So I don't want to use Q because that is a very good solution, and I don't care about good right now. I want to relate the solution of this with this vertical order. So give me a brute force approach. What if we cannot use Q? Then how will you do level order?
Using recursion.
Using recursion. Okay. How will you do using recursion?
पोस्ट ऑर्डर सॉरी इन ऑर्डर भी कर सकते राइट इन ऑर्डर से इन ऑर्डर में सबसे पहले हमें मिलेगा लेफ्ट नोड
इन ऑर्डर में जो भी मिलेगा वो इन ऑर्डर ही मिलेगा ना मतलब आर यू सेइंग कि विल डू यूज इन ऑर्डर टू गेट द लेवल ऑर्डर और यू सेइंग कि इन ऑर्डर क्या होगा
सो बेसिकली लेट्स से इन ऑर्डर लेंगे इन ऑर्डर में सबसे पहले हमें ये लेफ्ट वाला मिलेगा वर्टिकल वाला वर्टिकल ट्री में देख रहा हूँ हाँ वर्टिकल वाला देख रहा हूँ मैं ट्री हाँ वो मिल जाएगा, राइट।
Okay.
फिर हमें इन ऑर्डर के साथ हमें मिडल वाला एलिमेंट मिलेगा, उसका उसका पेरेंट बेसिकली।
Okay.
फिर उसका हमें राइट वाला मिलेगा,
This one in
या
order.
इन ऑर्डर,
Okay.
या
Okay.
उसके बाद हमें मेन रूट मिलेगा,
Okay.
एंड वी विल कंबाइन दिस, अभी इसके पहले मिला हुआ, देन रूट, एंड उसके बाद सबसे लेफ्ट में जाएंगे ना, फिर राइट राइट ट्री में सबसे लेफ्ट में जाएंगे, तो वी विल कंबाइन दीज थ्री बेसिकली।
So you're trying to get the vertical right now.
हाँ वर्टिकली से प्रिंट करवाना है, राइट।
Vertically is yes, we want vertical order, but I wanted to first solve this level order. Then we'll take the help of that level order to solve for vertical. But
Okay.
what you were trying for vertical, that will not work. I'll give you example where it not work. So everyone, what did you follow what he said? And I'll try to give ki wo nahi kaam karega what you just said. So okay, so Athar, you said ki you'll go to the
सबसे
left.
लेफ्ट, या
Yeah, this will be your one vertical, and then you go
हाँ
to the one
वो एक
vertical,
वर्टिकल हो जाएगा, राइट।
and you go to the right, and then that is next vertical, and then you
या
what do you do?
वी विल गो टू द पेरेंट ऑफ द दिस सेकंड वाला नोड, उसके
What if you
ऊपर वाला,
what if you have children? What will do?
फिर लेफ्ट में जाएंगे ना उसके। तो ये
Okay.
बेसिकली अभी जो दो ड्रॉ किए उसका पेरेंट पहले प्रिंट होगा ही नहीं, उसका लेफ्ट वाला होगा, राइट। हाँ
No,
उसके
so
लेफ्ट वाला पहले प्रिंट होगा ना
you,
अभी तो।
you printed this,
हाँ
you printed this or not?
यस वी प्रिंटेड दिस बिकॉज इट्स इन ऑर्डर।
And then we came here, and then you printed this.
नो बिकॉज इट्स इन ऑर्डर, सो वी विल गो टू लेफ्ट, राइट फर्स्ट। उसके लेफ्ट में जाएंगे ना पहले अभी। हाँ हाँ यहाँ पे जाएंगे, फिर उसके ऊपर आएंगे, और फिर राइट में जाएंगे।
Hmm.
हाँ पर यानी
While doing in order,
लेफ्ट रूट देन राइट, बट
yes. So while
बहुत
doing
बहुत कॉम्प्लिकेटेड है क्योंकि वी हैव टू कीप ट्रैक कि कौन सा लेवल पे क्या है, इट्स
yes,
नॉट गोइंग टू वर्क।
yes.
या
Okay. Let's come back to this level order, because using that only I'll make your vertical order thinking a little bit simple. So I'll give a brute force approach. हमें करना क्या है कि we have to find the level order. So it's just simple. For every level, get all the nodes. That's it. For every level, get all the nodes. So for level zero, what are all the nodes? How will you find? So the question reduces to another question now. This question is reducing to another question. Ki find all the nodes of a given level L. How will you do that? Find all the nodes of given level L. How will you do that?
We need to go to that level and we need to keep on checking whether our traversal is on that level, then we need to iterate all the nodes in that level. Like we need to keep on sending the level or something.
So okay, let's assume that we are able to find all the nodes in given level by some method called get all nodes at level L. Okay, we have this method and we can get all the nodes in the given level. So by using that method, we can just simply do a loop while or for I equal to 0 to I equal to less than a height for all the or less than level whatever I plus plus for all the level, we'll just call that get all nodes in that level. So we can simply do that, assuming that we have a method. Now, what I'm trying to say is the way we did that for all the levels, do this traversal one by one. Similarly, here for all the vertical levels, try to do this for all the vertical. Try to store everything for all the levels, all the vertical levels. So, what I want you to try, you can think of the solution, is suppose you have this storage, we have this all the vertical levels, vertical level X, vertical level from vertical level 0 से लेकर के 0 1 2 3 and then dot tail, suppose n. So for all the level there will be some nodes, node 1, node 2, node 3, node 4, like this. For all the level there will be few nodes, node 5, node 6, node 7, it can have node 8, node. So this is something like that we want to have at each level. So the one thing I wanted you to relate was we have to do this for all level, one by one. That kind of, so this was one by one, but if not, even if not one by one, while traversing we have to maintain things for all the levels. So for us to print them into, for us to print all the nodes in vertical order, we have to maintain that somewhere. So now if we just create a storage, an auxiliary store, which is what? Array of list of nodes. Array of list of nodes. If you store I have given you lots of hint now. One hint and the biggest hint is you can do this for a tree by maintaining a list for each vertical, level. So we started with a array. We started with the array, empty array, and we had nothing at each vertical level. But while traversing through this tree, while going through this tree, by in any order you want, we stored in this array of list of nodes. This is list of nodes. So this, all these array boxes have some linked list of nodes. So while traversing this in this any order you want, you know that what is the level of that node. So let's start with the first. Let's start with the first root. Now the level of the vertical level of that is not sure. I don't know what that is, but we'll assume that the vertical level of this is suppose 1000. Suppose this is 1000. This is 1000th level, or x. I can do anything. We can improve on this, but let's start with 1000. Now we know if we start with 1000, so this node will go into 1000th index. Let's call it x only. This will go to x index. Why I am initially with 1000 or something? Because I am not right now. I don't know how many levels can be. So I'll just think, okay, let's take the extreme case. We have root node at 1000th higher vertical level. So we at 1000th level we stored our root. Now once we have stored the root, we'll traverse both the side again, and this time we'll just change the level. Your level 1000 minus 1, your level 1000 plus 1. And every time we visit some node, we just try to insert into the linked list of that level. So what we're doing is we are simply calling recursively with a level passed to it. And whenever we visit that node, we check what we just insert that node into the past level. So we started with 1000th level, we inserted root node at 1000th level linked list, and then we went ahead, we called on 999 for next left node, and we called with 1001 for right node. So now left node will go into 999 index, and right node will go to 1001 index. Now when left node calls for the right children, it calls with the incrementing one. So again, for right child of left of 2, if you can see 1 2 3 4, for right child of 2, the 3 will be back into the 1000th level. So it will just append it to the root node. So at the end, what I'm trying to say is with every recursive call, we are passing it the node as well as its own level, and we starting with some level 0 or something, level 1000 something. We just assuming some level, and for every level we adding it to the linked list of that level. And at the end, when we have traversed complete tree, we have this array of linked list, and in the order of levels, and each level has this list of nodes, and we can simply print all the nodes in that linked list by traversing the linked list. Understood? Kuch doubt? So I spoke in one go. I did not stop, but what we are essentially doing again is we are maintaining the linked list in a linked list, all the nodes of each level. So for each level, it will start with an empty linked list. But whenever and we started with a suppose x level for the root. Now we know the X level or 1000th level will have this new element. We'll just append to that list. When we go to the left side, we change the level, we make it -1, we decrement the level, vertical level, and when we go on the right side, we increment the level. Now, whenever we reach a node, we'll first insert that node into its level, which is passed to it, and then we'll take care of the left and right side by again, left side will decrement by one more, and right side will increment by 1. So जो जिससे कॉल हुआ था उसी वाले लिस्ट में अपेंड हो जाता है. So at then what will be left with is an array of linked list. Each linked list will contain the node in that level. समझ में आ गया?
हाँ.
Anyone any confusion?
I think no confusion, but we'll try next class.
Yeah.
If it is possible. Yeah.
Okay, so we'll try. Assignment I gave you one assignment. One assignment I'm adding is print. Very simple. The simplest, the simple part of this. How to find or print the node in LS level. That's one simple code you have to write as soon as possible. Print all the nodes of LS level or KS level. That's it. Okay.
Okay.
Okay then. I will end the class here. I'll end the class here. Anyone, any question, you can stay. Otherwise, you can.
Okay.
Yeah.
Bye.
Thank you.
Praveen, I have a question.
Yes, sir. Okay.
Yeah, this is regarding class only. It's not about Kenny. So can we do like more classes this week or next week?
Try करता हूँ. मतलब we have missed again. We missed a lot of class. I understand. तो
नहीं, अब मिस किया हुआ इसलिए नहीं. द इशू इज मेरा इंटरव्यूज चल रहा है, यानी मैं 10 बार नहीं बता रहा हूँ पर इंटरव्यूज चल रहा है, और अगर ऐसा हुआ कि मेरा अगर कोई अच्छा कोडिंग इंटरव्यू अगर हो गया अभी बीच में तो बहुत मुश्किल हो जाएगा. ये सब कुछ मैं खुद से ही किया थोड़ा बाइनरी ट्री तो, बट बाकी के अगर डायनामिक और ग्राफ नहीं हुआ तो फिर प्रॉब्लम हो जाएगा. आई कैन एक्सटेंड. मैं उनको बोल सकता हूँ कि एटलीस्ट नहीं कि 2 हफ्ते 3 हफ्ते दो, बट आई कैन नॉट एक्सटेंड मोर देन दैट कि उनको. हाँ तो
so what I'm saying is I was doing a lot of theories, a lot of questions. Now we'll have to cover theory fast so that we can discuss random questions. So by the way, that theory बाकी नहीं है from the perspective of interviews. Very few theories are left from the perspective of interview. If you want to read data structures, lots of theory left. If you want to read about algorithm, lots of theory left, but from the perspective of
problem solving.
Yes, ज़्यादा नहीं बाकी है, तो we can cover. I'll cover. Let's do one class tomorrow also then, if everyone is okay. Let me think.
Sunday, can we do it on Sunday? Like one only.
We can do on Sunday, but let's try to be like हर दिन try करते हैं.
Consistent at least.
हर दिन try करते हैं, वरना फिर कुछ ना कुछ हो सकता है. So let's try tomorrow again. If anyone, I don't have any issue tomorrow. If no one has issue tomorrow, let's try tomorrow.
I'm also fine.
ठीक है. So hopefully things will be fine for me as well, because कुछ है नहीं, लेकिन एक काम आ सकता है. I'm not sure right now. Let's see. I'll try to make. अगर 9 बजे नहीं तो 10:30 तो कर लेंगे. ठीक है.
ठीक है.
So let's try to do tomorrow one more class. So and we'll try to cover.
So Professor, the only thing is try to complete this class as soon as possible so that we can practice ourselves.
Yeah. I'll be happy.
Yeah, मैं आपको प्रेशर नहीं डाल रहा हूँ, मैं जनरली बता रहा हूँ कि ऐसा सिचुएशन है, so उसके हिसाब से फिर.
I'll be happy to finish the class. मुझे फायदा ही होगा. चलो, bye then.
चलो, okay, yeah, bye.
Bye.